Hello, I'm Jonathan Martin, and anyways, I am just going to offer some tutoring services on math, chemistry, and physics. Not like too extensive on any of it, but basically your freshman year of college and anything within the high school spectrum. And the reason being is I'm fairly good at trying to break things down and meet you where the confusion starts and get past it. And I'm going to give a real good example, and that's polynomial division. And the confusion starts there for a lot of people when working with algebra, because it doesn't actually make sense. It just seems to be something to do to waste our time, right? Um, and in reality, it's probably one of the most important things, maybe not to be able to do consistently, but to understand fundamentally of in algebra. Because what it actually is stating is that any function that you're ever given, it can be broken down into another function that defies a set of rules, which is normally the case that a function is going to be like equivalent to, say, two functions multiplied together, or two functions added together, or two other functions, all with respect to the same x. There's this is a whole new condition that says there's a whole new case that it doesn't have to be a times b equals c or a plus b equals c. Instead, we can break it down even further into an always reoccurring scenario that we can have two different unique functions multiplied by each other plus a third unique function, and it's always going to be that case. And this is really cool because this allows us to add in addition, and it allows us to deal with really unique functions. So you can imagine it won't really affect most people's lives, but somewhere there's a scientist who is doing research, and he's gotten so much unique data that no list of functions that he has can combine, multiply, divide into each other to make this special scenario to represent this data. But what's really cool is we can now actually start adding in this extra function, which is r of x. And the reason why that's so cool is because this r of x can also be broken down into another f of x is equal to the same exact scenario. So whoops, we'll just do like this. And this can be repeated over and over and over again. And that lets us actually begin to create data that doesn't have to follow specific formats or follow trends, and it allows us to interpret things that we normally wouldn't be able to interpret. And I think that's really important because they don't stress the importance of it, and it makes it seem like it's just kind of like a lost art that doesn't have a cause or purpose. But in reality, we can look at some visualizations, like we don't need this one anymore. Like if we have a set of data here, this is the function, and we want to turn it into what's going on here, we can break down this red and green area as the equation of this red area times the green area, and this will add up to all of that plus the extra area left over, and it's always going to follow that format. It's always going to be able to do that. So that means when we're graphing stuff, we'll use a real simple parabola. If you have like a quadratic equation, you can actually express it in two linear equations plus a constant even. Now, as this becomes, say, like a fourth degree polynomial, you might actually express it into, for a quadratic equation plus or multiplied by a linear times or plus a whole nother linear. It's pretty complicated, but the point is you can start breaking it down until we get to the point where this kind of stuff happens at the end. And dealing with a bunch of simple stuff is way easier and way easier to understand than dealing with a bunch of complicated, or like a small amount of complicated stuff. And that's really what this is proposing. It's saying that we can simplify things, even if it takes a really long time, to a point that we can use it and collect data on it and start expecting trends. And that's important. And I think understanding, and I can leave that there actually for this one, so you can imagine, like, if this was, multiple humps here, that we could just do this same exact procedure multiple times and get it to a point where we have a bunch of small sets of data all adding to one cumulative thing. And the cool part is it doesn't have to just be like straight dividing the function or straight little multiple sets of the function. It can be like important subsets of the function, and that's important because it, like I said, just lets you start doing stuff with easier to use numbers. And that makes, like, when you start working with chemistry or physics, it kind of makes sense. It makes like, well, I can break everything down into the smallest things possible, and they're still related to each other. They still have something to do with one another. They're not their own little entities. And now that you know that, maybe trying to find a way to break down a polynomial into simple polynomials will seem more appealing, because it now has a purpose. And a lot of times we'll be able to FOIL, we'll be able to factor, and we'll be able to do other algebra tricks to get to where we're going. But sometimes that's not possible. But even when it's not possible, this rule always works. So you can always find a way to get it into this format. And in this case, we definitely have an x evolved, and then we have a -2. So I would propose that we use x maybe +2. That might be a little bit difficult because there's a 3x, so maybe x + 1, right? So we can do our this is our dividend, right? So we'll make a divisor that's going to be x + 2. Actually, let's do x + 1. So we'll do and this isn't really difficult. It's just tedious, but kind of understanding that it has value makes the tediousness okay, I think. So from here we have x + 1, and we have a 5x squared, and it just works like normal division. You would say, well, how many times can this x go into this 5x squared? And that's going to be 5x times, right? So you have 5x. And 5x, multiplied by x there, it's going to be 5x squared plus 5x. And we subtract this off. We'll switch to another color to go to the next step. And that's going to be 3x minus 5x is -2x. We'll drop this one down, it's -2. And now we want to say, well, what else is going on here? We have x, again, can go into this x squared how many times? It's a -1, so it'll go in -2 times. So we have a -2. And if we multiply this by this scenario, we have -2x minus 2. Subtract that out is the same thing as adding it. So this actually results, because -2x plus 2 is 0, -2 plus 2 is 0, results in 0. So we don't have any more remainders, so we can express this equation up here as now first part, which we'll call it 5x minus 2. The second part, which is going to be x plus 1. And the third part for this special one here, which is plus 0. And that's going to be equal to 5x squared plus 3x minus 2. And I know that this is a pretty simple explanation, but I hope it catches your interest into why polynomial division, despite being sometimes long and tedious, as it can be, is actually really a useful tool. It means that even when things can't be factored or grouped into smaller subsets that make sense, that we can still actually break them down into subsets, into a unique small, as feasibly as small as we can make them, unique subset, and study it and learn from it. And that makes solving really big hard problems long and tedious, but doable, with a lot of times just algebra on endless repeat. But yeah, it might not actually help you in your life ever, but in practice it is real important. And it's not just we're going to make you or anyone else looking at this do this really nasty, time-consuming polynomial long division just because we're evil. It's actually because it highlights a really cool concept in algebra, and that's the ability to break things down, no matter how complicated they seemingly are, into smaller, more understandable and usable entities that we can study and actually predict what's going to happen next. So yeah, I thought it was pretty cool, and hopefully my explanation of why I think it is cool will help help you decide that it's worth actually honing that skill up. It's not just to make you waste your time. Thanks for listening, and hopefully this piques some interest.